Now we are talking about the third lesson of Unit 1, which is talking about the atomic structure of the matter. Okay, as we talked before, that the matter consists of molecules, and the molecule consists of atoms. Okay, the chemist used the symbols to express these elements. The symbol of the element is represented by its atom. For example, if you know that the oxygen molecule, its atom is called O, capital letter of O. So the symbol of this element is come from its atom, which is O. Okay, the symbol is a capital letter, like the oxygen O. If the symbol consists of two letters only, so the first one should be capital letter and the second is a small letter. Okay, some symbols come from the Latin name of the elements. For example, if we have the sodium, its Latin name is called natrium. So its symbol is not SO or not S, because its name is natrium, come from the Latin name. So its symbol will be Na, which come from the natrium, the Latin name. So its symbol will be Na, the first letter should be capital, N capital, and A small. And here we have a table for the element and its atom symbol, and here we have some examples. First, we have the element lithium. Okay, we said that the symbol come from the atom of the element, and the lithium atom is Li. So the atom symbol of the lithium will be Li, which come from the lithium, the first two letters. The first letter is a capital letter, here L, and second letter, which is small letter I. Okay, the next example is the potassium. Okay, here in this example, the potassium, its symbol not BO. Why? Because the potassium has a Latin name which is called kalium. So here in this case, the symbol will be K, only K capital, which come from the kalium Latin name. Okay, the next example, which is the sodium. Okay, the sodium symbol not SO or not S, like we said, because its Latin name was natrium. So the atom symbol here will be Na, N capital A small, which come from the natrium, which is a Latin name. Okay, the next example will be the calcium. Here, the atom symbol will be Ca, which come from the original name calcium, C capital A small. Next, magnesium. Magnesium will be Mg, M capital G small, which come from the magnesium original name. Okay, next, aluminium. Aluminium, its atom symbol will be Al, A capital L small, which come from the aluminium original name. Next, zinc. Zinc, its atom symbol will be Zn, not Z only, but Zn, Z capital and N small. Next, iron. Iron, its name comes from a Latin name which is called ferrum. So the iron was called ferrum in the Latin name. So its symbol will be Fe, which come from ferrum. So the first letter will be capital F and second letter will be E small. Okay, next, lead. Lead come from Latin name which is called blamum. So here the atom symbol will be P capital and P small. Okay, next, copper. Copper come from the Latin name which is called cuprium. So here in this case, the atom symbol will be C capital U small, which come from the Latin name cuprium. Okay. Next, we'll have the mercury. Mercury comes from the Latin name which is called hydrogram. So its atom symbol will be Hg, which come from the Latin name hydrogram. So H capital, G small. Next, silver. Silver comes from the Latin name which is called argentum. So its atom symbol will be Ag, A capital, G small. Next, we'll have the gold. Gold also come from the Latin name which is called aurum. So its atom symbol will be Au, A capital, U small. Next, we'll have a neon. Neon, like you know before, that it was a noble gas, and its atom symbol will be Ne, N capital, E small, which come from the original name neon. Next, we'll have the hydrogen. So its atom symbol will be H, only H capital, because it's only one letter, and it's also come from the original name of hydrogen. Next, oxygen. Oxygen, its atom symbol will be O, only one letter O, so it will be capitalized, and it's also come from the original name oxygen. Next, we'll have the nitrogen. Nitrogen, its atom symbol will be N, only one letter, and it should be capitalized by N capital, which come from the original nitrogen name. Next, fluorine. Fluorine also only one letter, and it should be capitalized, which come from the original name of fluorine. Next, chlorine. Chlorine, its atom symbol will be Cl, two letter. The first one should be capitalized, and the second one will be small letter, and it's also come from the original chlorine name. Next, bromine. Bromine, it has two letters, come from the original name bromine, P capital, R small. Next, iodine. Iodine, only one letter, and it should be capitalized, which come from the original name of iodine. Next, helium. Helium, its atom symbol consists of two letters. The first one should be capitalized H, and the second one will be small, so it will be He, which come from the original helium name. Next, argon. The first letter will be capitalized A, and second will be R small, which come from the original name of argon. Next, sulfur. Sulfur, only one letter, and it should be capitalized because it's only one, and it's also come from the original name of sulfur. Phosphorus. Phosphorus, its atom symbol will be P, and because it's only one letter, so it should be capitalized because it's come from the original name of phosphorus. Next, carbon. Carbon, its atom symbol consists only of one letter, and it should be capitalized because it come from the original name of carbon. Finally, we have the silicon. Silicon, its atom symbol consists of two letters. The first one capitalized, second one small. First one is the S, second one I small, because it comes from the original name of silicon. And now let's talk about the atomic construction. What's mean by atomic construction? How was the atom is formed? Okay, like you know before, that anything around us is called a matter, and any matter consists of the simplest pure form of it, which is called the element, and the element consists of molecule. Molecule also consists of smallest unit of it, which is called the atom. So what's mean by the atom? Atom is the fundamental building unit of matter. What's mean by fundamental? Very, very, very small. So the atom, it is the fundamental building unit of matter. And if I ask you a question, scientific term, it is the fundamental building unit of matter, so it will be the atom. We have also another definition in another way, so it will be the smallest individual unit of matter which can share in the chemical reaction. So only the atom in the matter which can share in the chemical reaction, not the molecule, not the element. So the atom itself which shares in the chemical reaction. And here we have a design or the diagram of the atom in front of you. We'll talk about it later. Okay, now let's talk deeply about the atom. Scientists found that the atom consists of two main parts. If you look at the picture at the previous page, you will see that the atom like a circle, and it consists of a small circle inside it, which is called the nucleus. And if you look at outside the atom, you will see small parts rotates or revolves around it, which is called electrons. So if I ask you complete question, number one, the atom consists of two main parts, dots and dots. So the answer will be the nucleus and electrons. Okay, now let's talk about the nucleus, number one. Okay, like we said, the nucleus is found in the middle of the atom. So its location will be the central core of the atom. What's mean by central core? In the middle. Okay? So now let's talk about the nucleus consists of what? What is the components of the nucleus? If you look at the previous page, you will see the nucleus consists of small parts inside it. It's like the apple. Okay, imagine with me or mango. The mango itself is the atom, and in the mango we have a seed inside it. So this seed will be the nucleus. If you open this seed, which is the nucleus, you will see another parts. These parts are called protons and neutrons. Okay, so the nucleus consists of dots and dots, protons and neutrons. Now let's talk about the charge. Okay, you have to know that everything in the life is charged. What's mean by charged? Which carry positive charge or negative charge. Anything in life is charged. So now I need to know what is the charge of the protons and the neutrons, which are found in the nucleus. Okay, it's a rule for you. Don't forget it, that the protons are always positive charged. All the protons are positive charged. And the neutrons, what about the neutrons? Neutrons are not positively charged and not negatively charged. So what will be it? It will be neutral. What's mean by neutral? It's not positive and not negative. So it's neutral. Neutral means zero. Okay? It's don't carry any charge, not positive, not negative. It's a neutral. Okay? So if you know that the protons are positive and the neutrons are neutral, which mean nothing. Neutrons are nothing. So I will ask you a question to test your intelligence. What is the question? What is the charge of the whole nucleus? The whole nucleus, the charge. What is the charge of the whole nucleus? The nucleus, which consists of protons and neutrons. What is the charge of it? For sure, if you think, okay, the nucleus consists of protons and neutrons. Protons are positive, neutrons are neutral. So what is the majority here? The majority here is the protons, which carries a positive charge. So the nucleus itself will be positive charged. So it is a give reason question. Give reason the nucleus is a positively charged. Why? Because it contains positive protons and neutral neutrons. Okay? Now, before talking about the mass of the nucleus, I want to tell you an information about the electrons. Like we said, that the atom consists of nucleus, and around it there are electrons which are revolves around it. Okay? Okay. You have to know that the mass of the proton, which found inside the nucleus is very high. Okay, the mass of protons inside the nucleus are very high, and the mass of electrons which are found around the nucleus is very, 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 very small. So the question now, where is the most place which has a big mass in the atom? Imagine with me, the big mass is found in the proton, and the smallest mass is found around the nucleus. So the question now, where is the most place in the atom which the mass is concentrated very, very, very high? For sure it will be the nucleus itself. The nucleus is the most place which the mass is concentrated. Why? Because the mass of electron is very small relative to the proton and the neutron. Or you can say because the mass of the electron is very small and the mass of protons and the neutrons are very large. So you have to know that the mass of the nucleus is very, very high. If I ask you a complete question, okay, take care, very, very important. The mass of the atom, the mass of the whole atom is concentrated in dots, very high in dots. So the answer will be in the nucleus. Okay? Now let's talk about the second part of the atom, which is the electron. Okay, like you know, where are the electrons? Like we said, that the electrons are very small parts that revolve or rotate around the nucleus with high speed. Okay? Now, like we said, everything in life is charged except the neutron, which is neutral. Okay, now I need to know what is the charge of electrons. So the charge of electron, it's a rule for you. The charge of the electron is negative charge, negatively charged. So if I ask you complete question, the protons are dots charged, it will be positively charged. The neutrons are dots charged. No, they are not positively, not negatively, so they will be neutral or uncharged. The electrons are dots charged negatively. Okay? Okay. Now I need to know what is the mass of electrons. We said that they have very, very small mass, or you can say negligible, very, very small, and can be neglected. You can say that the mass of the electron is nothing for the mass of the proton and the neutron, because the mass of proton and the neutron very, very large and bigger, much bigger than the mass of the electrons. Okay, so the mass of the electron is very, very small and you can neglect it. Number. What is the number of the electrons? It's a rule for you. The number of the electrons that revolve around the nucleus equal to the number of the protons inside the nucleus. Okay, it's like a match between Barcelona and Real Madrid, and both of them scored, for example, 5 goals. So the result will be 5-5 for each team. So the number of electrons equal the number of positive proton. Again, the number of negative electrons equal the number of positive protons. So if the number of positive protons equals the number of negative electrons, so the whole atom itself will be electrically neutral. What's meant by electrically neutral? It's like equalizer, like the match. Both team score the same goal, so the result will be equalizer. So if I ask you, give reason, the atom is electrically neutral. Why the whole atom is electrically neutral? Why? Because the number of negative electrons equal to the number of positive protons. Okay, you have to know here some notes. Remember, that the charge of the nucleus is positive. Why? Because it consists of positive protons and neutral neutrons. Number 2, the charge of proton is always positive, positive charge. Number 3, the charge of neutrons is neutral, or you can say it uncharged. Number 4, the charge of electrons is negative, negatively charged. So the charge of all atom itself will be neutral. Why? Like the give reason question at the top of the page, that the number of negative electrons equal to the number of positive protons. Now let's talk about how to express an atom of an element, how to write the atom of the element. In Junior 6, we only wrote the symbol oxygen O. Now we need to express the whole atom. Okay, if you look at the picture here, we have the atom of the oxygen and its symbol will be O. And you must here see two numbers. One number at the top left of oxygen, and one number at the bottom left. What is these numbers? What are these numbers? Okay, the number which is written at the bottom left is called atomic number. Take care, because this information is very, very, very important. The number which is found at the bottom left is called atomic number. What's mean by atomic number? Atomic number, it is the sum of protons or electrons. It is the number of protons and electrons. Or you can say that the atomic number is the number of protons or electrons. Why? Why I said that the atomic number is the number of protons or electrons? Why? Because you know that the number of protons equal to the number of electrons. So I can say that the atomic number is the number of protons or electrons. So here in the picture, if I ask you, what is the atomic number of oxygen? 16 or 8? So it will be 8. Why? Because you know that the atomic number is the number which is written at the bottom left on the symbol. Okay? Now what about the 16? What about the number which is found at the top left of the symbol? It is called mass number. Mass number. What's mean by mass number? Mass number, it is a number which is the sum of protons and neutrons. Mass number is the sum of protons and neutrons. In another way, that the mass number equal proton plus neutrons. Okay? So again, what's mean by atomic number? It is the number of protons or electrons. Mass number, it is the number of protons and neutrons plus sum. So here in the same example, if I ask you a question, what is the mass number of oxygen? For sure it will be 16, the number which is found at the top left on the symbol. Okay, and you here have some notes. I wrote it at the bottom of the page, that the atomic number equal the number of proton equal number of electrons, because protons equal the number of electrons. Mass number equal number of protons plus number of neutrons. So if you are very, very smart guy, I will ask you a question now. If you know that the atomic number equals the number of protons and the mass number equal number of protons plus neutrons, so what is the mass of neutron? How can I find the mass of neutrons, the number of neutrons only? How can I find the number of neutrons only? For sure, you will subtract the mass number from the atomic number. So it's a rule, put it in your head, that the number of neutrons equal mass number, which is the number is found at the top, minus the atomic number, the mass is found at the bottom left. Okay? We have example for you to solve the problem. Number 1, if the nucleus of the sodium atom contains 11 protons and its mass number is 23, find the atomic number and the number of neutrons. Okay, first of all, we said that the number of protons equal the number of electrons equal the atomic number. So what will be the atomic number? The atomic number will equal the number of protons, which equal 11. In this example, he needs to know what is the number of neutrons. And we know we have a rule to find the number of neutron. We will subtract the mass number from the atomic number. So it will be 23 minus 11, so it will be 12. Now let's talk about the movement of the electrons around the nucleus. How are the electrons move around the nucleus? The electrons around the nucleus like the cars in the street. Did the cars move in any place over the building, over the trees, in the sea? No, absolutely no. The cars move in special ways for it. Okay, the electrons are the same idea. The electrons rotate around the nucleus at very high speed. In number of orbits or shells, the number of orbits or shell like the streets in the like the way of the street. So the nucleus move in a special way called shell or orbit. Again, the electrons move around the nucleus in ways. These ways are called orbits or shell. These orbits or shell are called energy levels. Energy levels. Again. The electrons move around the nucleus in orbits called dots, in orbits called energy levels. Okay. To imagine with me, the electrons move at very high speed around the nucleus like the fan. If you have a fan at your home, the fan consists of arms. When you switch on the fan, can you see each arm individually? No. Why? Because the arms are moving at very high speed like a one body. So the electrons are moving in energy levels at very high speed around the nucleus like the cloud, like the movement of the cloud around the nucleus. You can't see one electron. Why? Because they are moving at very high speed and seen as a one body, as a cloud. Okay, now I need to talk about what's meant by energy levels. Did the energy level is a real places around the nucleus? No, they are only imaginary places. We imagine them. Okay, so the energy level, they are imaginary places or regions. They are imaginary places around the nucleus in which the electrons move inside them. But take care, the electrons moves in these energy levels according to their energies. Like for example, if we have the electron A have energy 1, so it will move in the energy level 1. And we have electron B and it has energy 2, so this electron will move in the energy level 2. So you have to know that the electrons move in the energy levels according to their energies. Okay, now I need to know how many energy levels did we have. The maximum number of energy level in the atom is 7. We have 7 energy level around the nucleus to move the electrons inside them. Okay, these energy levels are arranged according from the nearest to the farthest. from the nucleus, from inside to outside. So here in the drawing, in this diagram, we have the nucleus here in the box, and after it the nearest one, 1, 2, 3, 4, 5, 6, 7. These energy levels have name alphabetically. The first one will be named K, L, M, N, O, P, Q, 7 energy levels. So we have the level symbol here, K, and its rank, the level number, it's number 1 level. L, number 2, M, number 3, N, 4, O, 5, P, 6, Q, 7. Okay? And you have to know, as when we go away from the nucleus, the energy increase. So if you are smart, what is the level which has the least energy, the smallest energy? It will be K, because it is the nearest one. And what is the energy level that has the highest energy? For sure it will be the Q, because we said as we go away from the nucleus, the energy increases. Now you have to know that each energy level of them has its own energy. Okay, each level has a certain amount of energy that increases by increasing the distance from the nucleus. As we increase the distance from the nucleus, the energy will increase. So for example, the first energy level is K, and it has the least energy, like we said. The seventh energy level is Q, and it has the highest energy. And by the way, the energy of energy level L is larger than K, because L is farther than K from the nucleus, but smaller than M. The energy, you have to know that the energy of the electron equals the energy of the level that rotate in it. For example, if I am electron and I have energy for 7 joules. It's information for you. The energy is measured in joule, like the length is measured in centimeter, meter, kilometer. The energy is measured in joule, but it's information for you, not in the method 1 syllabus. Okay, example, if I am electron and I have energy 5 joules, okay, so I will move in the energy level that has 5 joules, okay. And if for example Ahmed is an electron and he has energy 10 joules, so he will move in the energy level that has 10 joules. So you have to know that the energy of the electron equals the energy of the level that revolves or rotates in it. And take care, the electron can't transfer to a higher level. The electron can't transfer to a higher level unless it gains an amount of energy, and this energy is called quantum. Again, for example, if I am electron and I have energy 5 joules, so for sure I will move in the energy that has 5 joule, okay. I need to move to the energy level which has 10 joule. Can I do it? No, I can't transfer to a higher level. Why? Because your energy is very small. You must take or gain energy. This energy is called quantum. What is the quantum? This energy equal the difference between the two levels. For example, if I move in energy, it's energy 5 joule, and I need to move to the energy level which carry 10 joules. So what is the energy I need to move to the higher energy level? I move in the 5, and I need to move to the 10. So I need another 5 joules to move to the higher energy level. And if I take these 5 joules, I will be called excited atom. Excited atom. Again, the electron which moves to the higher energy level will be called excited atom. Okay? So now we have two definitions here. What's mean by quantum? Quantum, it is the amount of energy lost or gained. Amount of energy lost or gained by the electron when it transfers from one energy level to another. What's mean by the excited atom? It is the atom that gain a quantum of energy. We said if the atom gain energy to move to the higher energy level, it will be called excited atom. Now let's talk about the electronic configuration or distribution of the electron. How can we distribute the electrons in their energy level? Okay, you have to know first that each level from the 7 takes a definite number of electrons. For sure, for example, the energy level K can take only 2 electrons. So 2 electrons only will distributed in the energy level K. Another example, for energy level L can take only 8 electrons. So only 8 electrons can move or distributed in this level, and so on. Number 2, you have to know that the electrons are distributed in the first level K, then L, then M, and so on. For example, I can't put electron in L before K. No. You must distribute the electron ascendingly from first level K, then L, then M, and so on. Okay. How can we distribute these electrons? From my mind, from myself, I will put 4 electron in K, 8 electron in L. No, we have a rule. But this rule can be done only for the first energy levels only. What is this rule? The rule said the first 4 energy levels can saturated with electron by the rule 2n power 2 or 2n squared. What's mean by n? N is the number of energy level. N is number of energy level. But why? Why this rule only can be done on the first 4? Why not at the next 3 energy level? Because the atom after the 4th energy level will be unstable, not stable. So it's very, very important. Give reason question. The rule 2n power 2 is not applied to calculate the number of electron of energy level higher than 4. Why? Because the atom is not stable. Okay, so to calculate the number of electrons in each level from the first 4, you must apply the rule 2n power 2 or 2n squared. Here we have a table which distributes the electrons, the number of electrons in their energy level. We have here the level symbol KLMN, the level number of level 1, 2, 3, 4, and how can we calculate the number of electrons in each level. Okay, let's begin by the first one, K. K, it's number 1, N, number of level N. So how can we calculate the number of electrons? We said by the rule 2n power 2. 2 times n power 2. 2 times, what is the n here? N is 1 because it's level number 1. So 2 times 1 power 2, 1 power 2 equal 1. So 2 times 1 equal 2. So if I ask the energy level K, is saturated by dots electron, how many electrons? 2. Okay. For the energy level L, the L is number 2. It's the second energy level. So the number of electrons inside it will be 2 times n number 2. 2 times 2 power 2. 2 power 2, 4. So 4 times 2, 8. So if I ask you a question, the L level is saturated by dots electron, it will be 8. Okay, next M. M, it's number 3. It is the third energy level. So the number of electrons inside it will be 2 times n bar 2, 2 times n, 3. 2 times 3 bar 2, 3 bar 2, 9. 9 times 2 will be 18. So if I ask you a question, the energy level M is saturated by dots electron, so it will be by 18 electrons. Okay, finally N level. N level number 4, it is the fourth energy level. So if we want to calculate the number of electrons which move inside it, 2 times n bar 2, n, the number of level 4, it is the fourth one. 2 times 4 bar 2, 4 bar 2, 16. 16 times 2, it will be 32. So if I ask you complete question, the n energy level is saturated by dots electron, it will be 32 electrons. Okay, can I calculate the number of electrons for the n for O, B, Q? No. Why? Because the atom after the fourth energy level will be unstable. Take care. And you have here some important notes. Take care that the outermost energy level of any atom, what's mean by outermost energy level? The final energy level. The last energy level of any atom, the last energy level of any atom, maybe L, maybe N, maybe O, can't take more than 8. Take care, the outermost energy level of any atom can't take more than 8 electrons, except K level, which only saturated by 2 electrons. Very, very important note. Number 2, if the number of electrons in the outermost energy level of the atom is less than 8, so this atom is active. I need to say something for you, that all the atoms need to be active. All the atoms need to be active atom. No, I don't need to make an effort. I need to be inactive. Okay, so all the atom need to make their outermost energy level saturated by 8, to not make anything, to not make any chemical reaction. So if the electron in the outermost energy level of the atom is less than 8, so the atom will be active. I am less than 8, so I will make an effort. I will make a chemical reaction to be 8, so I am active now. So in this case, the atom will react with another atom. We'll make a deal. I need some electrons to be 8, and you need to lose some electrons to be 8. So let's make a deal. We will react together. Okay? And in the other way, if the number of electrons in the outermost energy level of the atom equal just 8, so the atom will be inactive. I am inactive. I will not make any reaction. Like all the noble gases, all the inert gases, argon, neon, helium, argon, radon, xenon, krypton, all the noble gases. So they don't react chemically with another element. They will not react because they are inactive. Okay, we said in any point react. What is the part that's responsible for this reaction? This part is the electrons. Only the electrons that can move from the atom to make the reaction with the electron of the other atom. So the electron of the outermost energy level are responsible for the chemical reaction. take care that the helium is the only inert gas that has two electrons in the outermost energy level. We said all the inert gas, all the noble gas are inactive, and all of them have 8 electrons in the outermost energy level, except helium. Why? Because the atomic number of helium is just 2. So helium is the only inert gas that has 2 electrons in the outermost energy level. Now to make this more clear for you, I know it's maybe a little bit hard for you. So now let's learn how can we make the electronic configuration, how can we distribute the electrons, this electron, in the energy level. Okay, we'll make some steps. The first, in exam, in any quiz, I will put for you 2 things. The first, I will put for you the name of the element, hydrogen, like this example, hydrogen. And I will put for you the symbol, hydrogen, H11. What is the one at the bottom? It is the atomic number. What is the one at the top? It is the mass number. So I will ask you to find the atomic number. Okay, it will be the one which is at the bottom. What is the mass number? It will be the number at the top left, which is 1. Okay. Now, let's make the electronic configuration. Now let's make the electronic configuration of the hydrogen. To make the electronic configuration of the hydrogen, we said we must draw the energy level. The energy level is like a big bracket, and at the top of it you will write the symbol of the energy level, the first one, second one, and so on, and at the bottom of it we'll write the number of electrons which move in this energy level. Okay, how can we get the number of the electrons which move in these levels? We said that the number of protons before equal to the number of electrons equal to the atomic number. So here in this example, the atomic number equal to 1. So the number of electrons will be 1. And we said that the K energy level is saturated by 2 electrons, and we have only 1 electron, so we will write it as it. So the electronic configuration will be K1. And in the second example, we have the helium. Okay, helium, its symbol He, I wrote it for you, 4, 2. 2 is the atomic number, 4 is the mass number. So how can we make the electronic configuration? We said to make the electronic configuration, we must draw the levels. Okay, first, we will draw the level as a bracket, big bracket. At the top of it, its symbol K, and the bottom of it, the number of electrons which moves in this level. Okay, how many electrons we have in the helium? We have 2 electrons, because we said number of electrons equal number of protons equal the atomic number. So we have 2 electrons. So how many levels did we need to distribute these electrons? We need only 1, because we said that the K energy level is saturated by 2. So we will write K2. Example number 3, lithium. Lithium 7,3. The atomic number at the bottom 1, 3, the mass number 7. So how many electrons we have in the lithium? We have 3 electrons. So how many energy level did we need to distribute these 3 energy levels? Okay, let's draw step by step. Finish step by step. We'll make the first energy level, K. The K is saturated by 2 electrons. So how many electrons are left? We have only 1 electron left from the 3. So we will put this electron in second energy level, which is the L. So L is saturated by 1 electron, which is the remain remainder of the electrons. Example number 4, nitrogen. Nitrogen N14,7. What is the atomic number? The number which is written at the bottom left, 7. Mass number, the number which is written at top left, 14. So, how many electrons we have in nitrogen? We have 7 electrons. So, how many energy level did we need to distribute these electrons? Okay, let's distribute step by step. First, energy level K, saturated by 2. So how many electrons left from the 7? 5. And we said that each energy level is saturated by 8 electrons. So the next 5 electrons will be in the next energy level, which is the L. So the electronic configuration will be K2L5. Example number 5, oxygen O16,8. Atomic number 8, mass number 16. So we have 8 electrons here, and we need to distribute them in energy levels. So the first step, the first energy level K, and saturated by 2 electrons. So how many electrons left? 6. So we will put them in another energy level, which is L. So the electronic configuration of oxygen K2L6. We have here some notes, like we said them before, that the mass of protons and the neutrons are very large compared with the mass of the electrons, which are negligible. Number 2, the element symbol come from its Latin name, such as sodium, and its Latin name was natrium, and potassium, which is Latin name was kalium. You have to know that the nucleus of hydrogen atom doesn't have any neutrons, so the atomic number equal to the mass number, because the hydrogen H11, the atomic number like the mass number. So here we have no neutrons. The number of protons may be equal to the number of neutrons, such as carbon, 4, or more than neutrons such as sodium, so the mass increase. And like you know before, that the electrons of the outermost energy level are responsible for the chemical reaction. Helium is the only inert gas that has 2 electrons in the outermost energy level, because it contains 2 electrons. You have to know that if the number of protons changed, we said the number of protons equal number of electrons equal to the atomic number. So if the number of protons change, the atomic number will change, and if the atomic number change, the mass number will change, and the element will change into another element. The first energy level K has the least energy, while the 7th energy level Q has the highest energy. And by the way, the energy of the level L is greater than K, and so on. The maximum number of energy level in the heaviest atom is 7, and we said each level has certain amount of energy that's increased by increasing the distance from the nucleus. So when the distance increase from the nucleus going so far, the energy will increase. And the energy of electron equals the energy of the level which revolve in it. And the electron can't move to a higher energy level unless it's gain amount of energy, and it's called quantum. And in this case, the atom will be excited. The rule 2n bar 2 is applied for the first 4 energy level, not applied on the levels higher than 4, because in this case the atom is not stable. The outermost energy level of any atom can't take more than 8 electrons, except K, which is only saturated by 2 electrons. The electrons revolve around the nucleus with very high speed in number of shells or orbits, which are called energy levels. The electron not transfer from level to a higher one unless it gain amount of energy, which called the quantum, and this quantum is the difference between the energies of the two levels. If the electron lose this energy, so it return back to the original level, and this state of atom is ground state. Again, if the electron lose this energy, it return back to the original level, and it's the state of the atom is ground state, the state of its beginning. Now we have a comparison table between some points. The first table is to compare between protons, neutrons, electrons according to the position, charge, and mass. The position of proton in the nucleus, also the neutron in the nucleus, but the electron around the nucleus. Charge of the proton positive, neutron neutral, electron negative. The mass of proton very large compared to electron, neutron also very large compared to electron mass, and the electron is very small compared to protons or electron. And here we have another comparison table between the active gases and inactive gases. The outer level of the active gases like oxygen, nitrogen contain less than 8 electrons, but inactive gas, the outermost energy level, the last energy level is completely filled with 8 electrons except hydrogen. The active gas, they take part in chemical reaction, and their molecule is formed of two atoms like oxygen O2, hydrogen H2. But the inactive gas, they don't take part in chemical reaction, and their molecules are formed of one atom like argon AR, helium HE, and so on.